Hello everyone, today we will be talking about a concept called recursion, and I'm going to show you how to utilize recursion in your own programs. Here are all the learning objectives that we're going to cover today. So we're going to talk about what recursion is, then how will we use it with our problem solving, and I'll show you a couple of examples of recursive algorithms. So what is recursion? Recursive module is a module that will call itself, basically. So it's just your regular module or your regular function that will just keep calling itself like a loop. But when this happens, we have a problem that might occur like an infinite loop, something that will just keep going and will not stop. So because of that, we have to, when we're using recursion, we have to make sure that our loop can eventually break away, and eventually that our loop in our recursion module will come to an end. Depths of recursion is just a number of times that a module will call itself. So for example, if your module calls itself 3 times, the depths of recursion will be 3, and so on. Here's an example of a simple recursion usage. As you can see here in our main, we're calling a method called message 5 times, and let's look at our module. So what do? We pass this 5 right here. We pass this 5 in here. And then what we do inside of the module is just a simple if statement. So as long as our variable times is greater than 0, and we start from 5, as long as it's greater than 0, then we will display this is a recursive module. Then we're going to call our module again, the same module. We're calling it again inside of the module. But this time, instead of using whatever is our variable times is holding, we're doing it times minus 1. By doing this, by calling it times minus 1, we assure that our recursive method has a breakaway. Has a breakaway. And why, you might wonder why that is. It's because of this little if statement right here. So we have if times greater than 0. And eventually, as we will call this method over and over again, our times variable will come down to 0. And then this module will just end calling itself. In general, when would we use recursion? We would use recursion when we have a problem that we can break down into smaller pieces. So remember how I told you whenever we started using modules, that why would we use modules? Just to break down our big piece of code into smaller codes. This same concept applies here too. So if you have a big module that you can break down into smaller parts, then you might want to use recursion. However, using recursion is never required, as you can use a loop and it will do just the same thing for you. However, in some cases, recursion is useful, such as in algorithms that I will show you later. So how does this concept work? So if we have a problem that we can solve just with one repetition, then we just solve it and end the module. However, if we cannot solve that problem with just one repetition of the module will reduce your bigger problem to a smaller but similar problem, and then it's just gonna call itself over and over again to solve the smaller program. So as I like to imagine, we have a big problem right here, right? Imagine that this is our big problem. Then what our module will do, it will reduce it to a smaller problem with one repetition, to an even smaller problem with the second repetition, and even so on, and so on, until our problem is solved. A couple of terms that you need to be familiar with: a base case. A base case is where a problem can be solved without recursion. So if you solve your problem without a recursion, that's called a base case. And a recursive case, similarly, it is a case where you use recursion to solve your problem. Just a couple of terms that you need to be familiar with. One example where recursion is useful is in calculating the factorial of a number. As we know, a factorial is a number that is multiplied by smaller numbers. So as you can see here, a factorial of 4 will be 1 multiplied by 2 multiplied by 3 multiplied by 4. This is what it means to have 4 factorial. Similarly, 5 factorial would be 1 multiplied by 2 by 3 by 4 by 5. And as we know, 0 factorial is always 1, because you will just have 1 multiplied by nothing, and that's going to be just 1. As I said, factorials are often solved using recursion just because it's way easier to solve those with recursion than just by writing a loop. Here's an example of how you would use recursion to solve a factorial, and it's just simple little piece of code right here, and we're just declaring an integer, a local variable that will just hold a number that a user will enter for us to calculate the factorial of, then another local variable to hold the factorial of the number after we calculated it, then we ask the user right here to enter a non-negative integer, and then here's the input where we take the input from the user, and then we are calling our factorial function right here. And then at the end, we just display what the calculation produced. And here is the function of the factorial that I showed you right here. This would be the function that your computer would call. And as you can see here, just a couple of if statements, just one if statement and one else statement. If n equals 0, because let's see here a parameter n, we're sending an argument right here. We would send what the user entered, and this where it would go. And then if that number is equals 0, then we would just return 1 because 0 factorial equals 1. However, if it's not, then we would return n multiplied by, and then we call our function again, but instead of calling it with n, we're calling it with n minus 1. And this way, your computer, whenever a user will enter, for example, 4, what it's going to do is going to pass a 4 into here. Then it would check, is our 4 equals 0? No, so it will skip to the else. And then it would go 4 multiplied by, and then it would call this function again, but instead of calling it with 4, it would call it with 3. So what will happen eventually after all of these calls? This is going to happen. 2, 1. This is all that's going to happen. So 4 is going to be multiplied by 3, multiplied by 2, multiplied by 1. And at the end, you will get a 24. The factorial of 4 is 24. You can calculate it yourself. You'll get 24. Here's a little diagram for you to understand a little bit better how those calls are made inside of our function. So you can see here we started with a value of 4. Then we would go again, started with a value of 3, 2, 1, and 0. And then it would just keep going back and returning the value to itself. At the end, we will get a return value of 24. So this would be all of the calls, how the calls are done, and then it would just go back with the return values. Here's another example of how you would use recursion to print out the Fibonacci series, Fibonacci numbers. And again, it's the same idea of using the recursion. So we create a local variable that's going to work as a counter for us. Then we just display a little message that says the first 10 numbers in the Fibonacci series are, and then we use our loop to call the function, to call the recursive function. So it's kind of like a loop inside of a loop. So as you can see here, for counter equals 1 to 10, we are going to call and display our Fibonacci function. And here is the Fibonacci function that's going to return to you the whatever amount of numbers that our user inputted in the Fibonacci series. For those of you who are not familiar with the Fibonacci numbers, it is what the Fibonacci numbers are is just after the second number, it's the sum of the two previous numbers. So as you can see here, we start with 0, then 1, then 1 plus 0 will be 1. Then 2 plus 1 is going to be 3. Then 5 plus 3. Then 3 plus 2 is going to be 5. So all it does, it just counts the two numbers that were in front of the next number. 3 plus 5, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34. That's all it does. And here is how you would solve it with recursion on this slide. Here are a couple of more examples of algorithms that you can solve with recursion, and one of them is the greatest common divisor, a recursive binary search, and the towers of Hanoi. If you are interested in that, I strongly recommend watching the videos on those. If I find some good videos on YouTube, I will definitely post them on our e-learning page. So if you're wondering when you would use recursion versus looping, I would recommend that at this stage of your coding journey, you would use loops instead of recursion. However, it is important to be familiar with the idea of recursion and that it exists in the coding world. However, here are some reasons why you would not want to use recursion. Well, it is less efficient than iterative algorithms because of all of the overhead that's happening. However, it is also harder to understand what's going on inside of the recursion. So if you're not quite comfortable with writing your own loops, you should definitely not write recursion because it is harder to figure out where the problem is and what's happening with the recursive algorithms. However, with the speed and the amount of memory that's available to our computers right now, well, the overhead factor is not really an issue anymore. So if you want to try and use recursion, you should go ahead. However, I would recommend that you focus on loops more. And again, recursion versus looping, it is strictly just a design choice and whatever the coder feels that they're more comfortable with and what they prefer to work with. Here is one example in Python that I'm going to show you of the very first example that I showed you with the pseudocode. As you can see here, this is how you would write a recursive function in Python. So we have our main, and then we are calling the function called message, and we are passing a number 5, an integer 5, to our function. Then this is our function message right here, and we have a variable called times, the parameter, and we're passing 5 as an argument to our parameter. Now, this is our if structure right here that will help us break away from the recursion. Remember that it's very important to break away outside of our recursion. And what we do here, we have times, as long as times more than 0, we're going to print this is a recursive function. And then we're going to pass a whatever number we have in times minus 1 to our function again. So as you can see here, this function will call itself over and over again while times is more than 0. So it's going to do it 5 times and it's just going to print this is a recursive function 5 times, and then it's going to break away after times reaches 0. So this is all I had for today, and let me know if you guys have any questions. Yeah, cheers.